Hello friends, today's question: 2 moles of ideal helium gas are in a rubber balloon at 30 degrees centigrade. The balloon is fully expandable and can be assumed to require no energy in its expansion. The temperature of the gas in the balloon is slowly changed to 35 degrees centigrade. The amount of heat required in raising the temperature is nearly. In this case, it is given that the helium gas is a rubber balloon and the balloon is fully expandable. So important term in this the question it is that is fully expandable and it requires no energy for its expansion. So we can assume here that the gas is undergoing a isobaric process, that is constant pressure. Therefore we are going to find out the heat required is determined in this case for constant pressure, that is Cp. And we have a helium gas which will be a monatomic, and we are going to use this basic concept in order to find out the heat required, because for isobaric process the heat required, that is Q, is given as N times Cp multiplied by delta T. So let us start with the given information that the balloon is fully expandable. So we can say that the balloon is fully expandable therefore from here we can say that the gas is undergoing an isobaric process. Isobaric process. So which basically means constant pressure. So therefore we are going to find out the heat using the heat capacity at the constant pressure. You can say from here the heat required is determined using heat capacity at constant pressure. At constant pressure, that is our Cp. And we also know that helium is our monatomic, so therefore the heat capacity, that is a value of Cp, will be equal to 5 by 2 times R. Therefore we can say for monatomic, which is our helium gas, Cp is equal to 5 by 2 times R. Value of R we already know, that is our 8.231. So we can write this as 5 by 2 times 8.31, and which comes as 20.775 joules per mole Kelvin. Now we are going to find out the heat required under the isobaric process. We can say heat required for isobaric process, which is our Q, it is N multiplied by Cp multiplied by delta T, where N is the number of moles of gas, number of moles of gas, Cp we already know, and delta T is the change in temperature. Delta T is our temperature change. So we substitute the values. We can write our Q is equal to, we are given 2 moles, Cp we just found out is 20.775, and delta T is our 5 Kelvin, because 30 to 35 we are supposed to do it, and we solve this will be coming as 207.75 joules, and the option is close to is option number D, that is 208 joules. So let me write it here, approximately 208 joules. So we can say option D is correct. Option D is correct. So this completes the question. Thank you.